Welcome, everybody. This is the KubeVirt community meeting, August 14th, 2019. First up on the agenda is KubeVirt version 0.20.1, and I will turn it over to Mark.
Yes, hello. Last Friday, we released version 0.20 of KubeVirt, and unfortunately, we had a little bug in our release process, so no manifests were published to GitHub. So we went on with the next release, 0.21, and that worked. And I added a link to the agenda notes where you find the release notes and all manifests now. That's it.
All right. I don't imagine there's any questions, but feel free if you do have any.
I guess maybe, is there some release note to know that how I can upgrade from the .19 to this .20 or .21?
There should be something in the user guides about doing updates. I can search for the link.
Okay, I'll just kind of poke around for that. But upgrades like this should be pretty seamless, like existing workloads and VMs remain running and all this stuff.
Yes, at the end, the easiest thing is that you deploy the newest version of the operator, and that will upgrade all other components, but running VMs will keep running. So the launcher is not updated on the fly, but only during the next restart, I guess.
Okay, that sounds good. Thanks.
You're welcome.
All right, and next up on the agenda, we have pod network and migratability and other behavior, and I will turn it over to Fabian.
Yes, hello, this is Fabian. So one topic that was a little bit discussed was the pod network and additional interfaces. So we've been, there were some side conversations about how, no, let me start different. So we have the pod networking and pod network, and that can be bound, or we have interfaces inside the VM, and those interfaces can be bound to different networks. The networks can be provided by Kubernetes, that's the stock pod network, or they can provide by other networking plugins like Multus or the SRI Vita plugin, or even Genie or Calico, which we don't support yet. All of this meshed together means that a VM can have zero or more network interfaces, and all of these network interfaces can be then mapped to one of the networks available to the VM at the pod. Now, that's a little bit complicated, which is annoying, and we want to clean that up down the road, but it might take some time. One step, however, we wanted to do, because we had trouble with that in live migration, was the pod network. So the pod network is provided by Kubernetes. So when you start a pod, you usually get a single pod, which is provided by Kubernetes. Because it's the pod network, it has certain constraints, and that is that these pod network behaves like Kubernetes is defining the pod network. So once you start a pod, an IP is assigned to that pod, and it will be, it is available for as long as the pod is running. When the pod is shutting down, that IP is given back to a pool and reassigned to a new pod whenever a new pod is coming up and needs an IP. Now, this behavior is problematic for live migration. That's actually where the problem came up. So when you live migrate a VM, what is happening? You start in one pod, right? The VM is started there and it's getting an IP. When you live migrate the VM to a new node, a new pod is scheduled, the VM is live migrated over to that new pod, and the old pod is taken away. And then the VM is living on a new node and a new pod. A new pod is the key point here, because new pod means new IP, right? Now, the VM does not notice that it's getting live migrated. That also means that after the live migration, the guest inside that VM is not reachable anymore through that pod network, because the VM is listening for one IP, that is of the old pod, but the IP it has when looking from the outside is the IP of the new pod, which is a different one. So there is a disconnect between the inside and the outside. In theory, we could solve that problem by saying, A, VM, please refresh your IP and get the new one from the outside. We could do that because we're using DHCP to provide the IP from the outside to the inside. The problem is that the DHCP clients we looked at don't support these forced DHCP refresh. And that's a problem because we can't resolve that situation reliably for every guest to get that new IP. and that's bad. So there was some discussion to say, all right, if we cannot enforce a new IP on the guest after live migration, we either need to live with that, but that's not so, but that would lead to a connection loss after live migration. But live migration can happen transparently. So what does that mean to a user? To a user can mean that now my VM is connected, and in some other minute, it's just disconnected. And you've got no idea why that is, and that's bad. So what we were thinking for the pod network is actually a different way to connect the VM to the pod network, and that is using Slurp or Masquerade. So what is the difference to the previous method I was describing? When we're connecting a VM to the pod network using Slurp or masquerading, both of them are NAT-based methods, right? So doing network address translation. Then the VM will have one link local IP, which is only local to the VM, and which is not the IP it has if you look from the outside. The benefit is that after live migration, the VM keeps the same IP, and it's still reachable because there's network address translation happening when the traffic is coming into the pod and going to the VM, and vice versa. So when it's going out of the VM into the pod network. The biggest drawback, however, is that the guest, so inside the guest, you do not see straight away what IP you have on the pod network. And that's problematic, for example, if you think of, and that was the use case which actually raised awareness that there's also a strong problem with that approach, is that if you use kubeadmin to inside of a KubeVirt VM and you use kubeadmin to join an existing Kubernetes cluster, then this will fail with this new approach because kubeadm is only seeing that link local IP address and not the public address of the VM anymore. So that is problematic in that use case. So we have two bad situations. In the one way, we break the connection of the VM and it can't use the network at all anymore, and it comes by surprise. In that other case, the migrations are covered, but for certain use cases, it will become more difficult to enable them, like the kubeadm use case.
So can I give some thoughts?
Sure.
That's a great explanation of the problem we have. I think there's a simple solution for this. We just disable migrations for the pod network. I'm not sure why that is such a big deal. There's definitely use cases where migration isn't even that critical necessarily. It's something that I guess would be nice, perhaps, but also there's tons of use cases where it's also okay just to shut down the virtual machine and bring up another one somewhere. So why can't we just disable migrations for the pod network? Because we know it's just not going to work. It's very niche. Like I can't actually think of it actually ever being useful with the live migration with the pod network. So disable it entirely. Say if somebody tries to do a migration and the VMI has the pod network attached with bridge mode, just no, you can't do that. So if you want live migration support, then the current solution is we have to use this one of these NAT solutions that keeps a consistent IP address and a consistent MAC for the VMI internally.
Yeah. So, Vladi, I see you want to speak. Just let me please reply quickly. Yes, I think we can do that. We can block live migration if bridge mode is used. Although I wonder if we need to, because if the guest is aware that this can happen, then they can do countermeasures. My point is, I would like to switch the default, right? For the pod network, I would like to switch the default to a NAT-based method, but leave the bridge as an option. The problem with bridge, furthermore, besides the outlined problems, is that, and there your David and mine opinions differ, right? It's problematic to make that work for every network plugin that exists for Kubernetes and for every kernel and for every operating system, because so many things are involved. Network plugins are different. Depending on the implementation we end up with for the bridging, because that can be done with TC or it can be done with IP tables or just routing, right? So bridging. That is, it all depends on so many factors that I'm not not positive that we'll reach a stable and a stable solution which is working everywhere. So my take is, let's use a natted method as the default, because then we can live migrate, but keep the bridge there for people who know what they're doing, so that they can enable bridging for the pod network to get that that behavior as well.
Well, by that logic, we wouldn't be changing the default because of live migration. It would be changing the default because the bridge mode is difficult to support. Because I think, let's say the bridge mode was completely supportable and worked 100% of the time across all hosts and operating systems and hardware, whatever. Would this discussion be happening?
Can I ask this? So to translate David's proposal, basically he's saying we should not be using the pod network because we can't control the IP. I think the problem is that there may be other solutions where we also can't control what IP the new pod's going to get, which would, so just saying we can't use the pod network doesn't necessarily completely solve the problem, because there can still be other cases where we can't control what the target of the migration is going to have, right?
That's another problem, yes. But to go back to David's question, no, we wouldn't be having the discussion if there's an optimal solution where we can meet all requirements. But I doubt that we will get there.
I just wanted to say that as it is right now, we don't support live migration with bridge on the pod network. So this is disabled already, and we also have an option to specify which default interface do we use for live migration. I'm not entirely sure that we need to change the default. We can just let people select which interface do they want for as a default.
Yeah, I mean, we speak about the same default we want to provide out of the box, right? And the default binding mechanism we want. I mean, after all, we need to understand a single NIC attached to the pod network is the default we provide when we are starting VM, when there's no further configuration done, and if you don't opt out. And that is the case I would just want to cover. You know, what is our safest configuration for that default case? And I'm proposing to say we use a natted solution for this case because it's most portable, it's most compatible with Kubernetes, and we would even have live migration there. The drawback is, as said, that that it's not straightforward to get the public IP from within the VM, although we can make that easily work. By the way,
you can provide it through some sort of metadata server or something like that. Yeah. The thing is, I can't think of a single VM management platform that does this. That's the surprise that I would have if I'm porting an existing workload over to KubeVirt and then my application's booting up and it detects ETH0 and its IP address and it registers it with whatever service for it to contact back. The stuff just wouldn't work, and I would be surprised to learn what's going on. And my immediate, it's a roadblock to porting over existing workloads because we are doing something special here that is abnormal.
That's fair. That's fair. I agree.
I would actually say that I would prefer to have that consistency of seeing the actual IP address within the guest OS over live migration based on based on my previous experience with using this stuff in the wild. But that's just my personal use cases that I've encountered. I know that there's a much broader set of use cases that do care about live migration, but I can speak from myself that I would prefer IP consistency within the OS versus live migration support.
About that, David, I have a question. So let's say if we leave it like that, so I am a developer and I import my VM workload and I don't change anything. I use the regular bridge. and my VM is running and I'm happy. And now the cluster admin need to put the host in maintenance mode. So the only way I can do it, it's by killing my machine. Without, I don't even going to know about it. My VM is just going to kill and go and start in another place. If I looking, let's say, on Rev, so my VM will be live migrated and the host are going to be into maintenance mode. So it's not exactly the same scenario here.
That's one use case. There's also, and it's actually more common, I would say, speaking from people that maybe are familiar with AWS or some other cloud, public cloud providers, that your VM can go away at any time. It could go away and it can come back, and there's no guarantees with respect to being live migrated. So people are also familiar with the opposite of that. I'm saying that both are valid, like both are important. Some people actually care exactly what you're talking about if the nodes go into maintenance mode, we want to live migrate workloads off of that. There's other people who have built applications within virtual machines who understand the risk of some other virtual machine platforms that aren't Rev, that their virtual machine will just go down, and they need to design workloads that can just reappear somewhere else and be resilient to that. So they're both valid, and they're both things that we need to support.
So maybe one note. So, I mean, when we started KubeVirt, right, we knew that we would encounter situations where we have, where we are constrained by what Kubernetes can do. And back then we said we favor Kubernetes compatibility over virtualization features, with the assumption that we'll find workarounds to provide the virtualization features in some other way. And first, that's the case here. So for the feature to have a stable IP along the lifetime of the VM, we can use additional interfaces provided by Motos. So we have a solution there to enable that. But what is more important, what I want to say actually, is to say that it's a hard call first. It's not easy, right? That is why we're discussing it for so long, actually. David, I would say you're right, but these are VM management platforms. And KubeVirt, right, with KubeVirt, we aim to run legacy VMs and other workloads on top of Kubernetes. But for most, Kubernetes is a container platform. And we need to adjust to that. And we should, and virtualization features come second, although we want to provide them. So following this guideline, just let me close the sentence. Yeah. But following that, even if I understand you, David, I would still say I would go with the local approach, because there are other solutions if you need the classical virtualization behavior. And we cannot reliably provide a stable, no, we just can't provide the same functionality on the pod network as people are used to it in the virtualization world. We cannot provide a stable IP and live migration. Both are common features on the pod network. And because we cannot achieve both and we would need to make a call, I would rather say then we break with the user experience in general and say pod network only works according to the Kubernetes rules, and the total virtualization experience can only be delivered using additional NICs.
I don't consider live migration to be part of the total virtual machine experience. It's a feature of the experience, but I don't know. There's use cases that don't require it.
David,
I think that's the
I need to step in really. What I wanted to say to Fabian is that what he said was really, really dangerous, because it defeats, basically negates the need for KubeVirt. If virtualization comes second, why we are developing KubeVirt in the first place?
No, I don't think that's what he meant.
But that's what he said, and it's really dangerous.
Well, hold up.
What you said, let me finish the sentence as well. What you said right now is the same thing. For virtualization, live migration is totally essential. If you don't have live migration, you don't need VMs.
Virtual machines virtual machine management without live migration. So there are use cases.
Yes, but they don't support what companies are looking for.
I've worked for
Workbox,
companies.
for example, there was OpenStack that never supported live migration before, I don't know, 2 years ago or something.
That's not true.
There was no live migration in the past, Vladik. I'm pretty sure that was the truth.
It was live migration before I left Red Hat in 2015.
In OpenStack.
Yeah, that's what I was
2
working
years
on.
ago. I think we don't want to eat up all the time. I just wanted to share the whole context, and which is very hard to put into text. Maybe we can take it back again to the mailing list so that we have time for other items as well. I just wanted to share my background and the context of that.
So is this whole discussion about defaults? I mean, this is the only left item, right? Because there was this pull request that basically this one that I shared that completely disables the bridge interface for certain workloads, and I thought that this is the center of the discussion, but we're focusing on the defaults. Is that right?
Well, yes. It comes down to that the pull request you posted is the thing that catalyzed this larger discussion. On the one hand, the point of view is, why are we supporting something we don't intend to use? And the pushback is, but we do use it. So then that's how the discussion changed to what should the default be.
Yeah, so yeah, Vladik, I saw that PR, and I know that people want to drop the bridge mode, but I think that might be too harsh, because in the end, you know, a VM will, without Multus, we just have the pod network, and we need to give people the choice, and people are educated, right? Or we need to give educated people the choice, given that they know what the constraints of their choice are. And so I would rather be in favor of discussing the default and leaving the bridge mode as an option, but rather just discuss the default. I think by now I would not favor to drop the bridge mode in general.
Yeah, I agree.
Can we?
One
go
comment
ahead.
about just one quick comment about dropping. So the PR, it's not dropping, it's only giving a flag. You can drop it, because again, I think the one that needs to get like the decision if in the cluster you will allow to use bridge or not should be the cluster admin. So you need to have a way you can block your users to configure it, because the user doesn't know the underlay cluster, what are the requirements there.
Personally, I'm not sure I understand the distinction.
So let me try again. So we want to have like a flag so the cluster admin can configure the KubeVirt config, right? It's not like any user can do it. And we want to give the administrator of the cluster the option to disable a bridge on a pod network. Let's say he wants to be able to migrate all the VMs. The SLA that the admin of the cluster have with the developers is you don't have a reboot on your virtual machine without know it or something like that. So if we don't introduce this flag, I as a developer can go and just create not a default bridge interface, do it explicitly, just say I want to create a bridge on the pod network, and that's it. And the VM will get this type of connection, and now the admin of the cluster can provide the SLA that he said he can do, like live migrate your virtual machine if you need to maintain the node.
Okay, so then that's a philosophical question about whether the choice should be up to the admin or up to the user, because admin knows best in this approach.
Exactly.
All right,
All right.
well, go on, Fabian.
I was about to say the exact same word. All right, let's continue.
Yeah, I don't think we're going to reach a consensus or a decision point here, just judging by the way the conversation's going. So I think we should table it and move back to the mailing list, but at least we all have the greater perspective of having talked about it, at least face to face. So next topic is GPU or vGPU pass-through, and I'll turn it over to Fabian.
Yeah, I don't think that Vishesh is around, but I still wanted to mention it in this forum. So Vishesh from NVIDIA was actually doing some design work around NVIDIA GPU and vGPU pass-through. And he was also sharing that on the mailing list, and he shared a PR. I think the broad design looks good to me, at least, and there's a discussion going on about it. To me, the one remaining question really is how do we handle the specifics about passing through the device and how the responsibilities are split between device plugins and KubeVirt to set up the underlying devices. But I think that's something that can be worked out. Any feedback is welcome. So, yeah, that's it.
Okay, doesn't sound like there's any questions. So next up is discussion about the IPMI connector, and I will turn it over to Kevin.
Keith.
I apologize.
It's fine. So I've been tasked from a customer request to add an IPMI type connector to our KubeVirt managed VMs as an option. I've got a design document because I've been looking at both the code for KubeVirt, which is about 2 weeks old, so it's not my current copy, is not the most recent, and my example implementation, which is virtual BMC from the OpenStack group. So, documented my touch points where I can adjust virtual BMC to be instead of doing libvirt type operations, it will go talk to KubeVirt to initiate those types of things. So if a IPMI event occurs, instead of having libvirt shut down a machine, I would redirect the request up to KubeVirt and say, you go manage this, go handle it, go take care of it, so that Kubernetes and KubeVirt can stay on sync. And that's the major goal right there. I'm in the process of developing a Go-based KubeVirt client so I can work out the right messaging method, and then I'll start modifying KubeVirt itself to talk to those methods and get the virtual BMC to talk back to KubeVirt as needed. And then that's my major points. Other than feedback on the document for any kind of design questions or assistance would be greatly appreciated. And I'll be submitting PRs. And as far as virtual BMC, I may fork that because they may not be acceptable to the deep changes that are needed to make it stop talking, to add an option to talk to KubeVirt instead of just libvirt.
So I did see the document, and unfortunately haven't responded on it yet. But I did see that one of the options being discussed was was surrounding the question of should it be a daemon per node or a daemon per cluster, and with that, if you had only a centralized daemon to do all this coordination, that would then require some sort of way to reach each node and enact the IPMI event. Is that correct?
Well, if I had like one IP that was my IPMI daemon, and each of the IPMI listeners are on a unique port at that point from the virtual BMC. So VM1 would be 6230, VM2 would be 6235, depending on how you configure it. That can be a centralized daemon source because this IPMI listener never talks to the VMs. It would receive that IPMI command and turn around and say, KubeVirt, go do this. So any kind of IPMI senders, the advantage of a centralized daemon is any kind of IPMI senders only needs one IP and needs to know the port of the thing it wants to talk to. And no matter where that thing ends up in the overall cluster, it can still send IPMI requests.
Okay, no problem. I guess I had seen an earlier iteration of the spec where it was being discussed to use SSH to reach each node, and I was going to push back gently on that. But if it's going to be using a Kubernetes client to reach out to KubeVirt, then that shouldn't be an issue.
Correct. I lined that out like yesterday, yesterday early, because that was an early iteration of me, mentally working the design. And, I think it's much better if I just, make my IPMI handler talk to KubeVirt and not worry about libvirt for any kind of operations.
Okay, that makes sense.
Hey, Keith. Good
Yes.
to see that action. It's Fabian or Fabian. Yeah, one thing that prevented me from participating in the discussion was if the IPMI protocol is actually a per node protocol, or if a single IPMI, right, not virtual VPC, but IPMI protocol would allow to manage multiple nodes from the same VMC. And I think the answer is no, right? So you have a single IPMI instance for every node you want to manage. Is that true?
Well, what can happen is I can have a single IPMI instance, but multiple ports. So like right now, my test host, I have one IP, but I can manage 4 VMs because it's listening on different ports. So there's a port to VM relationship instead of a port IP and VM relationship.
Okay. Yeah, that's okay. Yeah, and I got that from the discussion, so that helped me. Because to me, one of the key questions really is if we, this IPMI service could be an add-on service, in my opinion, because it can be a standalone Python script which is just mapping the IPMI calls to the relevant KubeVirt calls. So changing the VM spec or whatever. And I wondered if it should be an add-on service, or if we want to, for example, integrate it into the Virt handler to do that stuff. And I wonder if in the group here, if there are opinions, if we'd rather see this as something that's integrated into the handler, or an extra add-on service.
I'm conflicted. I think on the one hand, you've got, if you make it part of the Virt handler, what you're basically saying is, this is so useful that everybody would want this capability across the board. On the other hand, if you make it an IPMI, or excuse me, an add-on service, I don't know which direction is better.
Yeah. In general, Keith it's probably easier to have it as an add-on service as a start. And if we see over time that is important enough, then we can still consider it to see how it's getting integrated into core KubeVirt. Would that work for you, Keith?
Yeah, I'm okay with that. I'm okay with it being an add-on service, and that'll let the maturity of the implementation improve to where it can get implemented. Because right now it's Python, and all the rest of your code is Go. So that's a Go IPMI implementation, and there's a couple of reference libraries that I haven't looked at to see how well they're implemented. So yeah, I'm happy with it being an add-on service.
Nice. Yeah, on that same matter, it might be, maybe it's helpful. I know that we currently don't have a forced shutdown for VMs, but we're actually looking to add that, and I think IPMI might be the first consumer for that feature, because ultimately IPMI is about enforcing certain states. Yeah. Cool. Thanks.
All right. Thanks, guys. The document's open for everybody to make comments, and I have my emails attached to it, I think. If not, I'll add that real quick.
All right. And without any further discussion on that topic, is there anything else for the agenda and notes today? All right, moving on to the open floor. We have our first sponsor for the CNCF submission, I heard. Is that true?
Yes, it is. So the submission is still open, And the process is that we need 2 sponsors to get KubeVirt sponsored into the CNCF sandbox. Liz volunteered to be 1 sponsor. Now hope that we get a second one soon as well. If you're working for a company, one thing that's helpful for that submission is and which was requested when we were presenting it to the TOC, was that companies, a diverse set of companies is stating that they're using KubeVirt. And if you're working for such a company which is using KubeVirt and you did not already comment on that pull request, then I would kindly ask to state your company and your use case of KubeVirt on that PR, and that might help us to find another sponsor.
All right, and next up we have a KubeVirt paper was accepted at the Open Source Summit 2019, and I will turn it over to Mr. Peril.
Okay, just to let you know, we submit this paper of KubeVirt 101 maybe a couple of months ago, and was already accepted the last Monday. Will be on October, if I remember correctly, at 28 or 29 on Tuesday. We will be here. We will be there.
Awesome. If anybody can make it, please do attend. And one more note about the KVM forum, and I'll turn it over to Fabian.
Yeah, I think the KVM forum is co-located with the Open Source Summit. And yeah, just a heads up, it's traditionally a place where a lot of virtualization people hang around, and actually one talk got already accepted. That's the KubeVirt project status update. But the schedule is not out yet. Yeah, just a heads up.
Okay, and with that, is there anything else to bring up today?
Yeah, maybe just one thing. There was, a while back, there was a PBC 64LE PR or fixes. And I've been in touch with them, and we really would like, we're working to see if we can actually add PBC 64LE support to our releases. That requires that we have CI for it, but resources were provided. I'm just mentioning it here to give other people who have interest in that topic to speak up as well.
Awesome, thank you. Okay, I think we have reached the bottom of our list. So thank you everybody for attending, and see you next week.
Thank you. Bye-bye.
Thanks. See you.
Thank you. Bye.